So before we get started, because we're going to be doing the review for test 2 today, and Devin, I think it was maybe you that sent me an email, but I just now got to all my emails from this weekend. It was not due last night. It's due this Sunday, the 14th. But remember, if you did do it, you can still do it again. You can do it as many times as you want. The test reviews, and then the grade book only records your highest score. Okay. Now, also, we're going to have to readjust our week this week. I don't know what I thought I was going to be able to get this review done in one day. That is impossible. It's going to take 2 days. So we're going to do we're going to start the review for test 2 today, finish it on Wednesday, and then we'll do 8.1 on Friday. So those will be the 3 assignments due this Sunday. I've already gone in and changed the due dates. And I'm going to send out an email announcement also that just re-says what I'm saying right now. The only assignments due this Sunday, the 14th, will be review for test 2, and 8.1. Now, that being said, we can't keep taking 2 days of class to do test reviews because, you know, we're already behind because of the snow week. So from now on, instead of doing test reviews during live class, I'm just going to pre-record them. So that way you'll still have a video of me working out the review. It just won't be live during class, okay? But so that's what I'm going to do for test 3 and test 4, because we have 2 more tests after this one. So we're going to do the review live in class today and Wednesday. But then for test 3 and test 4, I'm just going to pre-record it and put it in your course content folder for that week. Okay? We just can't keep taking up this much time to do test reviews. Okay, so let's get started with this one though. So what I'm going to be doing right now is this review for test 2. And we will get through the first 13 of them. And then we'll do 14 through 25 on Wednesday. Now, the first question is asked, it gives you a picture of a graph and wants to know about its, whether it's even, odd, or neither. So let's re-go over what that means. This is an example. Like the parabola that we look at all the time. Standard x squared graph is symmetrical with the y-axis, right? And when you are symmetrical with the y, here's my y-axis, and if you folded this side over this side, or you can just look at each side mirrors itself across the y-axis, that is an example of an even function. An odd function is like the x cubed graph. Odd functions are symmetrical with the origin. And here's what that means. Think about this. If I folded, or it needs to be symmetrical with the x and the y. So think about this. If you folded this on the x, it would come up here and come up, it would look like this, right? If you folded this part and flipped it up here, it would now look like this. And then flipped it across the y, then it would lay on that other side. So that is an example of an odd function, if you're symmetrical with the origin. So number 1 on the review, all this is leading up to number 1 on the review. The graph looks like this. So which one would this be? Is it symmetrical with the y-axis, making it an even function, or is it symmetrical with the x and y, which makes it an odd function? Which one does it go with? Even, right? It's symmetrical with that y-axis. Okay? All right, the next problem goes with that transformation section. The numbers that shift each graph horizontally or vertically? So let's look at this one. The graph is g of x equals x plus 3 squared plus 5. So it's going to say, you're going to start off with the graph of f of x equals. Well, what this is asking you is what's going to give it the shape of this graph. What is the original graph going to be before any shifts? Well, this right here is what tells you, that's squared. So the graph that you're going to be shifting is an x squared graph. And then it's going to give you two more blanks. It's going to say, the first blank is going to say, it's going to shift blank 3 units and blank 5 units. So on this one, what's shifting it to 3 units? Well, this 3 is in here. So remember, that's an inside number, right? It's inside the parentheses. And what do inside numbers do? They shift you left or right, but you go opposite the way the sign tells you. So since that's a plus 3, it's actually going to shift me to the left 3 units. And then the last blank says, where is it going to go 5 units? So here's what's shifting at 5 units. That's an outside number. Outside numbers shift you vertically, so up and down, and you go the direction that this is telling you. So since that's plus 5, I'm going to go up 5 units. Then it's going to ask you to graph it. Now remember, this one's a little different than other graphing questions in this section. When it's asking you to graph it, remember when you're graphing in Math Lab, the first thing you have to do is come over here to all those different shapes and tell it what shape you're going to draw. So since it's a square, you would choose that U parabola shape, and then you click absolutely anywhere on the graph. What it's going to do on this section is it's going to put your parabola right there at the origin, and then you're going to, down here in the right bottom corner down here, that'll be your shifting buttons, right? Remember that section where it shifted it horizontally? So you'll shift it horizontally to the left 3, and then vertically you'll shift it up 5, which will move, once you do that, once you're telling it that, it'll move this to the left 3 and up 5 and put it where it's supposed to go. All right, number 3, f of x equals the square root of x minus 2. So it says it's going to start with the graph of square root of x and then shift it blank units. So this first blank is going to give you a drop down that'll say right, left, down, or up. So let's see, what is this going to do? Since it's an inside, right? It's inside the square root, which means it shifts it horizontally, but opposite the sign, which means where is a minus 2 going to, what way is it going to shift you? It's going to shift you to the right 2 units. And then it's multiple choice from there, right? The only one that shows you that's been moved to the right is that B one, right? That's the only one that has that square root shape that's been shifted to the right. Right, number 4. Okay, number 4, the function is g of x equals negative x minus 2 squared plus 3, and then it's going to have all the shifts. The first one's going to say shift it blank units. It's going to give you a drop down to choose from. Every option will be right or left, which means it's talking about this inside move, right? If your options are right or left, that's always talking about an inside move, which is this one. So where am I going to be going? My inside move is telling me to go to the right 2. So you just, it'll say that one of the things will say right 2 for your multiple choice part right there. Then the second one says reflect across which axis? So remember, what does this negative do to this U-shaped parabola? It flips it upside down, right? That's what the negative does, is it flips it upside down, which just means it's reflecting it across the x-axis, right? Here's my x-axis. If a regular parabola looks like this, that negative reflects it across the x-axis, or in other words, flips it upside down. And then the last one, all the options in my drop down are going to be saying up or down, which is talking about an outside number, right? Outside numbers are what shift you up and down, and you go with the sign. So what is this plus 3 going to shift? Up 3. All right, number 5 and number 6 are both on finding zeros of a quadratic function or an x squared function, okay? Which means if you have the program in your calculator, this is literally 3 points. All right, so if you're finding the zeros and it's a quad function, you're literally just going to your calculator. If you don't have the program, this is the week you want to get it, right? So you would just go, turn your calculator on, hit the program button. If you have a bunch of programs like I do, you'll just go down until you see the word quad. Hit enter and hit enter again. It's going to ask you for the A, B, and C, which is A is always in front of your squared term. Your B, this time is in front of B. And your C is your constant, which means your A, B, and C are 1, 12, and 27. So that's what you tell your calculator. A is 1, B is 12, and C is 27. Hit enter, and there's your 2 answers, -3 and -9. Number 6 says again, find the zeros. F of x equals 2x squared minus x plus 9. So again, if you've got the program, what are you doing? Here's your A, B, and C. So your A would be 2. Your B, in front of this X, you'll see a -1. And then your C is 9. Yeah. I'm going to show you, I'm not going to work it all the way out, but I'm going to show you the difference in the two answers and what that means about those two problems. Okay, so let's look at this one using the quad program. So my A is 2, my B is -1, and my C is 9. Look what it gave me for these two answers. Okay, I have 1. Then it separates them. On the calculator, you have 1 plus I squared is 71/4. And then the next answer is 1 minus I. Now remember, there is a plus minus button in MathLab that you can type all that in as 1. So those are your two answers. Look at the difference in these two answers. They both said to find zeros, which are the answers to these quadratic functions. This one, the answer was just plain -3, -9. This one looks all crazy. If you have a radical in your answer like that, that means you had to have used the quadratic formula to solve it. So if you don't have the program, you're going to have to use the quadratic formula. We don't have time to work it all the way out using the formula, but you can go back to that video. We did work a couple out using the whole formula. Okay? This, if your answer doesn't have a square root left in it, that means you could have solved that one by factoring. By doing the two factors and setting the two factors equal to 0 and gotten your two answers that way. Yes, there should be, like if you were typing this answer into MathLab, what I would hit first down here at the bottom is, this one that looks like this. That means you're about to tell it that you're about to type in a fraction. So I would hit that to tell it I'm going to type in a fraction. Then I would hit 1. Well, down here, there's all kinds of different things down here. There's one that looks like this that says you want to type, that's going to make you be able to type in an exponent. There's one down there that has that you can actually hit that so that you don't have to type in two completely separate answers. This is two answers. It's just that that's the plus one and that's the minus one. That button should be down there with all those other tools that are down there. It is? Yeah. Yeah, good. Paul?
I figured out there's a way to use the exponents without having to hit that button.
How do you do that? Oh, that puts you up in the exponent? Okay, so yeah, I didn't know that. So yeah, so this right here, you can also hit Shift 6 apparently to type in an exponent. That's good enough. Number 7. Okay, so this one gives me a function, x squared minus 2x minus 8 equals 0. But then it actually gives me the picture of what that would look like on the graph. Okay, so there's the graph of x squared minus 2x minus 8. And it actually even shows you these 2 points. And then it asks you, what are the x-intercepts? Well, the x-intercepts are where the 2 points where that parabola crosses through the x-axis. So just be careful when you type in your answers here. These, if it's asking for X-intercepts, it actually wants what are the coordinates of those points, not just the number where it crosses. So the coordinates of the points means it wants the ordered pair. So where is this one crossing? Since it's crossing the x-axis at -2, the ordered pair for that would be -2, 0, right? The y coordinate's always going to be 0 on that x-axis. This one crosses through at +4. So it'll be at 4, 0. And you know how MATLAB is. If you don't have this comma, it's going to mark it wrong. Okay? Anytime something like that ever happens, all you have to do is shoot me an email. Right? I do not mind going in and giving you credit for that. I've also had somebody that on one of their points, they put a period instead of a comma because those buttons are right next to each other on the keyboard. Okay? I know what you know that that's not supposed to be a period, right? So if anytime you have some like little thing like that and it's just because MATLAB didn't like the way you typed it in or you left a comma out or something like that, all you have to do is send me an email. Okay, so those are the X-intercepts, and then it wants to know what are the solutions. Well, the solutions are just the X coordinates. Or if you use the quad program to solve that, the answers that you get, which would be -2 and 4. Now that part of the answer doesn't have a parentheses around it, right? Because if you put parentheses around that, you are telling MATLAB that you are putting in a point. Well, there's not a point at 2, 4. That's not what you're trying to tell it. You're trying to say that the solutions of this equation are 2 and 4. So just be careful on how you type those answers in on that one. All right, number 8. All right, 8 and 9 are the application problems for the quad functions, and they both deal with right triangles once you draw out what the sentences are talking about. Okay? What it expects you to already know, because it doesn't tell you in the problem, is that when you are dealing with triangles that have this right angle like this, that you can solve them using the Pythagorean theorem, which is a² plus b² is equal to c². With one of your sides being A, one of your sides being B, it doesn't matter which side those are. This has to be your C. Okay, so it assumes that you already know that the Pythagorean theorem is a² plus b² equals c². Okay, now let's read the problem. The first one says a wire is stretched from the ground to the top of an antenna tower, which means this is my wire, right? Here's the ground being stretched to the top of the antenna tower. So here's a wire. The wire is 10 feet long. So I'll also know that this side is 10. The height of the tower is 2 feet greater than the distance from the tower's base to the end of the wire. So the height of the tower, so here's my tower, is 2 feet greater than the distance from the base of the tower to the base of the end of the wire. So this side is 2 feet longer than this side. So what I'm going to do is call this side, if that side is X, what does it automatically make this side? Well, whatever that side is, add 2 to it, right? That's what the problem tells me. This side is 2 feet longer than this one. So now I have set up something where I can use the Pythagorean theorem to solve it for X. So what does it want me to do? It wants this side squared, so X plus 2, squared plus the other side squared, so there's my x squared, and make that equal to, this side is called the hypotenuse, this side, which is 10 squared. If I can break this all down and solve it for x, then I'll know what this side is. And if I know what this side is, I'll just need to add 2 to it to get that side. So I need to, once you're looking at this, you notice that your highest exponent is a 2, which means this is a quadratic equation. I just have to set it up to be able to solve it. So I can solve any quad equation using my quad program, which just means I just need to know what A, B, and C are, right? Well, in order to know that, to put in your quad program, everything has to be on one side set equal to 0 so that you don't get the wrong signs. Which means I got a lot of work to do on this. So what does x plus 2 squared mean to do? Multiply that x plus 2 times itself, which means I need to FOIL here. So my first, x times x gives me x squared. My outside, x times 2 is 2x. My inside, 2 times x gives me another 2x. And then my last 2 times 2 is 4. I can clean this up a little bit by putting those two x's together, right? I can put those together. So I'm really going to have x squared plus 4x plus 4. So that took care of this part. I'm just dropping down this x squared equals, the other side is 10 squared, which I can now write as 100. Still got some work to do. Look at the left side. I have an x squared here to x squared here. I can put those together since they're like terms. Right, I have 2 x squareds on the left. So I've just put my x squareds together. This one and this one. Just bringing over the 4x plus 4. So plus 4x plus 4. I still have that equal to 100. So I still have one more step left to go to get this set up so I can put it in my quad program. This needs to move to this side, right? You got to set it equal to 0. So I'm going to subtract 100 from both sides. So there's my 0. On the left, I have 2x squared plus 4x. And I put this minus 100 under that 4 because that's its like term. So I'm going to have minus 96. Now, everybody's on one side, set equal to 0, which means I can use my quad program to solve this. So what's in front of x squared? 2. In front of x is 4. And then your constant is negative 96. So let's put that in our quad program in our calculator and see what we get. So A is 2, B is 4, C is negative 96. Now, how many answers is this going to give me? It's going to give me 2 answers, right? So let's try and make this make sense. I've got a 6 and a negative 8 as my solutions for x. What is x representing? Here's my x. It's representing the distance from the base of this tower to the end of the wire, which means one of these, because of its sign, is not going to make sense. What can a distance not be? It's not going to be negative, right? If you're a distance, you're some kind of positive number, right? So that one just can't work, which means this side is 6. And this side, since it'll be x plus 2, so 6 plus 2, which is 8. So just make sure you get those in the right spot. The distance from the wire to the tower would be 6. The height of the tower, well, here's my tower. So its height would be 8. All right, number 9 is another Pythagorean theorem problem, but because of the information that is given to us, it works out a little differently. Okay, so it's going to be another one. It says the foot of an extension ladder is 7 feet from a wall. So here's my ladder. Well, if the foot of it, which is that is the bottom of it, is 7 feet from a wall, here's my wall, that means that side is 7. The height that the ladder reaches on the wall, so that's this distance, and the length of the ladder are consecutive integers. So what that means, if you're consecutive integers, that means one comes right after the other. So if these two are consecutive integers, if this one's x, that one just means it's going to be x, just add 1 to it to get to the next number. So let's set this one up using the Pythagorean theorem. So this side squared, which will give me x squared, plus the other side squared, so 7 squared, equals the hypotenuse squared. So x plus 1 squared. So let's see, over here on the left, I've got x squared plus 7 squared is 49. When I do this on the other side, I'm just going to do it over here to the right a little bit, and then put my answer down here. So x plus 1 squared means to do x plus 1 times itself and FOIL it. So let's see, x times x gives me x squared. My outer x times positive 1 is 1x. My inner positive 1 times x is another positive 1x. And then my last 1 times 1 is 1. These x's can go in the same basket, right? They're like terms. You really have 2 x's. So you've got x squared plus 2x. Plus 1 there. So that's what's going to come here. Right? X plus 1 squared worked out, gave me x squared plus 2x plus 1. Now, here's why this one works out a little bit different. I do notice that it's a quad problem because it's x squared. But when I'm taking the steps, which would be to get all your terms on one side to set it equal to 0. Watch what happens. The first thing I'm going to move is my x squared. So in order to move it to the left, I need to subtract it off this side, which means I also have to subtract it off the left. Well, when that happens, what happened? It canceled both of them. So now you don't have any x squared. So let's see what's left. On the right, all I have is 2x plus 1. On the left, all I have is 49. So no x squared, and all I'm trying to do is figure out what x is so that I can find the length of this ladder. So I just need to solve this for x now. So I'll subtract the 1 from both sides. So 2x equals 48, and then divide it by 2 to get x equals 24. Just be careful when you answer this problem. Where does x go? This is x. So that side is 24, which means the hypotenuse, which represents the ladder, is 25. And that's the only thing the question is asking you is how long the ladder is, which is 25 feet. All right, number 10. Gives us the graph of a parabola, so a quadratic function. So it gives me this graph, and then it even labels this point. That's what that negative 1, 4 is in the picture. Then it's going to ask me 3 questions. The first thing it's going to ask me is, what is the vertex? Don't make this any harder than it is, right? It actually tells you what the vertex is. It's saying that this point, because the vertex is the point that the parabola changes directions. So that vertex is at negative 1, 4. It's going to ask you what the axis of symmetry is. The axis of symmetry is the vertical line that cuts this parabola right in half and what makes one side mirror the other. It even tells you right next to where you're typing in the answer, it says make sure that you type an equation, not just a number. So the equation of this vertical line, all vertical lines have the equation x equals. Well, what does the x equal at every point on this vertical line? What's going to equal the same thing it equals at the vertex? So x equals negative 1 is the equation of the axis of symmetry. And then it wants to know what is the minimum or maximum value. Anytime they're asking you about a value of a minimum or a maximum, they're asking you the y. That's always going to be the y. Y is always your value. So what is this one would be a minimum, right? Since it's the bottom of the parabola, the value of that would be 4. Not y equals 4. We're not talking about the equation of a line. We are just talking about a number value. All right, number 11 gives me a function, but it doesn't give me a picture, and it doesn't tell me what the vertex is, but the vertex is what I'm going to need to know. First of all, it's going to ask me what the vertex is, and then you use the vertex to answer all the rest of the questions. All right, so there is the function, and it's quadratic, so it's going to make a U shape. And the first thing it's going to ask me is what is the vertex, okay? There is a written out way to solve this, but remember, we can also do this in our calculator. You don't even have to have a special program. Everybody can do it. The first thing it's going to want you to do is to put that in your y equals. So we're actually going to go to the y equals and clear it out. And put 2x squared plus 10x plus 9 in it. And graph it. Let's look at it. So the first thing you're going to have to know to be able to find the vertex is whether or not you're searching for the minimum or maximum, right? Because the vertex is this point right here where that U changes directions. So is that the minimum or the maximum of this one? That's going to be the minimum, right? Because it's at the bottom. So the way you find the vertex is you're going to hit the second button and then hit your trace button, which is right next to the graph button. Because you're actually going to get up to this blue calc. So we're going to calculate the minimum, right? So hit enter. Now, the first thing you're going to have to tell it is the cursor on the left side of this parabola? Now, these numbers down here tell you where your cursor is. The cursor right now is at 0, 9, which means it's right here. Which means it's not on the left, it's on the right side of it. So I need to hit my left arrow key. Whoops. So there, you see your cursor more now. So I'm hitting it to the left until I pass through the vertex. Doesn't matter how far on the left side. It just needs to be past the vertex. So hit enter. Then it's going to say, is the cursor right bound or is it on the right side? So now you're going to hit the right arrow and move it back past the vertex to get it on the right side of your parabola, then hit enter twice. Here's where your vertex is. Negative 2.5, essentially, right? If you have negative 2.4999999, that's not what MathLab wants. It wants negative 2.5. Actually, it doesn't even want that. We'll talk about that. Negative 3.5. So when you are typing in the vertex, it's going to say type an ordered pair using integers or fractions, which means not decimals. This is definitely handy though, because you do have to graph this one. And when you're moving that cursor around on your XY coordinate grid, it's not moving it around in fractions. You're seeing decimals, right? So this is handy. But for this part of the problem, it wants you to type these in as what their fraction equivalent is, okay? So just go to your home screen, type in the decimal, so negative 2.5. Uh-oh. Negative 2.5. Hit enter. You don't even have to hit enter, really. So hit, and then hit, remember how you turn decimals to fractions? Math, enter it. So that what needs to be entered as negative 5/2. Do the same thing with your negative 3.5, which will give you negative 7/2. So there's the vertex. So the axis of symmetry is going to be the vertical line that goes straight through this vertex. So it's always x equals, and then just look at your vertex to see what the x equals. So with this one, does this one have a minimum or a maximum? So you can either look in your graphing calculator to see what the shape of it is, and it's this way. And the x squared is not negative. That's what would have flipped it upside down. So this one has a minimum, because its vertex is at the bottom. And what is its minimum value? Negative 7/2. And then you are going to have to graph this one. So just that's when this is going to come in handy. Because the first thing it's going to say is to plot the vertex. All right, number 12. Is a true-false. And it's kind of back to one of those shifting problems. So here is my function. The graph of h of x equals x plus 5 squared can be obtained by translating the graph of x squared left 5 units, and it wants to know, is this true or false? Well, let's see. That's an inside number, which does shift you left and right, but you do go opposite the sign, right? So plus 5 does shift you left 5 units, which makes that true. one for today, and then we'll wrap it up on Wednesday, is number 13. Of x equals x squared minus 10x plus 24. So it wants to know all the same stuff plus a little bit more. So let's put this one, it's going to start off with the vertex, which again helps us with the rest of the problem. So let's find the vertex in our y equals. So go to y equals, clear it out. Type in x squared minus 10x plus 24. So let's graph it. So there's my parabola. The first thing it's going to want to know is its vertex. This one has a minimum, so we need to tell it that we want to find the minimum of this parabola. So we find the minimum by hitting the second button, and then the calc, which is right next to the graph, and tell it we want to find the minimum. So go down to minimum and hit enter. Now, remember, the first thing it's going to ask you is it on the left? Well, here's where the cursor is. It is at 0, 24, which means it's about right here. So I need to make sure it's on the left side. Is that the left? It's hard for me to tell from backwards. Yes, it is on the left. If you aren't sure, move your cursor down to where you can see it. So move it to the left. I mean the right, sorry. So see it coming down the Y? I want to move it down so I can see it. So it's coming down the Y. So I should be able to see it soon because my window is set to where the highest Y is 10. So now that it's below 10, look, you can see it right there at the top. So it is on the left. So go ahead and hit enter. And then keep moving it to the right. So you get over on the right side, anywhere, and hit enter twice. So here's my vertex, 5, -1. So this one asks me some different questions. The first thing says, this one does have a minimum, right? Because it opens up. So it opens upward and has a minimum value. What is the minimum value? What number does that come from? The value is always whatever the Y is. So the minimum value is -1. So here's what that parabola looks like. Its vertex is at 5, -1. So to the right 5 and down 1. So because the next thing it's going to ask me is, what is the range of this function? The range is your Y values, right? Well, you just told me in the previous part of this that the lowest Y, the minimum value, is -1. So that's my lowest value. What does the range or the Y values do from here? They go up, which means the range starts at -1 and goes to infinity. Now let's think about, we know what infinities have, right? They always have parentheses. This -1 is actually going to have a bracket around it, right? Because -1 is part of the range. It is included. It does pass through -1. So there's my range, and then it wants to know the increase and decrease. So let's label it. This side, the values are coming down, so that's my decrease. Once it passes through the minimum, then it starts going up, so that's my increase side. So the first thing it wants to know is, where is it increasing? When we're talking about increasing, we're always using parentheses and the x coordinates. So let's see, where does it start increasing? It starts increasing at this point. which means I use that 5. So 5 to infinity. The decrease, well, 5 is where it stops decreasing, right? That's the end of its decreasing interval. So 5 is at the end. Where does it start decreasing? If your arrow is going to the left, that means you are coming from negative infinity. So it decreases from negative infinity until it gets to this point. Once it gets to that point, it starts increasing. So from 5 to infinity. Okay, I know I went a couple minutes over, but we will start with number 14 on this on Wednesday. I got everybody that's online and I got everybody that's in here. So we'll see y'all Wednesday to wrap this up.